Good morning friends. Today I will discuss you electron displacement in covalent bond. You see, in organic compounds, bond is formed between the two atoms by sharing of the electrons. That is known as covalent bond. This sharing of the electron may be single bond, double bond, double bond. Now, how the displacement of the electron takes place in the covalent bond? Today I will discuss you electric effect and the electromoric effect. Electric effect. You see, in the case of the tetrahydrocarbons, this electric effect is found. It is a permanent effect. Now, if you take an example of a long chain compound where at one end is having the more electronegative atoms. For example, a chain of the carbon atom 1, 2, 3, 4, at one end it is a chloro atom, and we know chloro atom is more electronegative. So what will happen? This shared pair of the electron will shift it toward the chlorine atom and it become enriched of the electrons that become negatively charged. Now the very important thing that this carbon which is nearest to the chloro atom become positive charge. What will be stability of this carbon atom? The point is that when this carbon atom become positive charge, what will happen? How it will remain stable? So what happens to maintain the deficiency of the carbon atom 1? Carbon atom 2 give electron to the carbon atom 1, and in the same way carbon atom 3 will give atom to the carbon 2, and in the same way carbon atom 4 will give the electron to the carbon atom 3. So subsequently this attraction of the force will be toward the chloride ions. So in this way carbon atom 1, 2, 3 they get polarized, and if we see in this case the charge will be, if on the chloro is negative, then positive will be the last carbon atom. So the point is that this inductive effect, which is a permanent effect, if we define it, process of displacement of the sigma electrons in a saturated carbon chain due to the presence of the more electronegative atom at one end of the chain. And this effect depends at the distance from the polar atom of the bond. And it was found that this force of attraction of the chloride ion, that is negative charge, decreases as the number of the carbon atom increases, and it was found that after carbon atom 4 this force of attraction of the chlorine atom is almost negligible. So the point is that inductive effect, that is effect of the electronegative atom in a chain of the carbon compounds, and this should be at the one end of the chain of the compound. Now this inductive effect may be negative or the positive. So when the atoms are withdrawing effect, there are the negative charge, that is NO2, chloro, bromo and the carbonic acids. They have a capacity to withdraw the electrons. And second is positive electric effect, where electron donating that are repelling, that is dimethyl, methane, dimethyl and the ethyl and methyl groups. So inductive effect, that is a permanent effect, and that is in the case of the saturated hydrocarbons. Now we see here, this is carbon and the chloride ions, that is, it is more effective, that is minus I, and here methyl group, that is donating, it is the plus inductive effect. Now this is a very important thing in the case of the reactions. Suppose this is a compound having a chloride ion at one of the end. What will affect? The shared pair is shifted towards the chloride, and chloride become enriched of the electrons and the carbon will become positive charge. Now it reacts with ROH. Now here say OH is negative charge. This attacking agent OH will go to the carbon atom which is deficient of the electron. So this inductive effect is very much important in the case of the saturated hydrocarbons reactions. Now second is electromagnetic effect. This effect is a temporary effect and it is found in the case of the multiple bonds, that is double bond and the double bond. And you know, if we take the example of double bond, one bond is sigma, which is a strong bond, and second bond is pi bond, which is a weaker bond. So here pi bond is taken to have an electromagnetic effect. We take example of the, that is carbonyl, that is ketone. Here oxygen is more electronegative, so pi bond shifted toward the oxygen. Now here one point is that this electromagnetic effect, which is temporary effect, is whenever there is attaching reagent, one thing, and as soon as this attaching reagent removed, it again regain its electronic configuration. Now this carbon bond, this pi bond, electron shifted towards the oxygen. Now oxygen become negative and the carbon deficit of the electron. When attacking reagent is, suppose here is a Z, which is electron, that is negative charge, electron rich. So it Z electron rich will join to the carbon atom because it is the deficit of the electron. Now as soon as this attacking reagent is removed, again it will regain its original electronic configuration. That's why it is known as the temporary effect. So if we define it, movement of the electron from one atom to the other in double bond or triple bond at the demand of the attacking reagent. So point is that whenever there is a attacking reagent attacks on the double bond, then this electromagnetic effect is seen. Now this electromagnetic effect, it may be E positive or E negative. If it is positive, that is donating, and if withdrawing, then it is negative. For example, if we take double bond, the pi bond shifted toward the carbon 1, then it becomes negative and it becomes positive. When attacked by the hydrogen, which is positive, goes to the negative carbon atom. And electron withdrawing effect is, that is example of the cyanide. Now the main difference between the inductive effect and the electromagnetic effect. Inductive effect takes place in the saturated hydrocarbons, while electromagnetic effect takes place in the multiple bonds. Second, inductive effect, there is no need of the attacking reagent, but the condition is that the electron donating or the withdrawing should be at one end of the chain. That is, here is the chloride ion, which is at the one end of the chain, because here drift of the electron will take place toward the chlorine. But in the case of the electromagnetic effect, that is temporary effect, here at the demand of the attacking reagent, this effect takes place by a pi bond. Okay, so this is the inductive effect and the electromagnetic effect. In my next video, I will explain you some more property of the electron displacement. So if you like my videos, please share and subscribe. Thanks very much.